This lesson was taught in my Honors Algebra 1-2 class with 9th grade students at the end of our functions unit. I used it as a performance task to assess their understanding of functions, specifically focusing on standard FIF B6. I chose to do the week 0 content assignment with my Algebra 1 classes. Students worked in groups of 2 to 4 and used whiteboard tables to organize their thinking. The main instructional approach I used was inquiry-based learning. Instead of demonstrating a procedure, I gave students a task and asked them to figure out how to approach it. My role during the lesson was to support student thinking through questioning rather than direct instruction. The task involved determining how long Avery's trip took, but students were not given a formula or method. Students had to decide what information was relevant. Many focused on unnecessary details like start time or speed. This created high cognitive demand because they had to make sense of the situation instead of applying a procedure. Students used multiple strategies, including diagrams, time reasoning, and tables. One thing I want to emphasize is that this task was intentionally designed to feel a little unclear at the beginning. Students did not know immediately what to do, which is different from a typical math problem, where they can identify a formula right away. This is important because it forced students to engage in sense-making. They had to interpret the situation, decide what information mattered, and test different ideas. I also noticed that because there was no single obvious entry point, different groups naturally took different approaches. This created opportunities later for discussion because we had multiple strategies to compare. I started with a warm-up about distance versus time to activate prior knowledge. Students then created a T-chart of what they know and what they wonder. There were 6 groups working at whiteboard tables. I initially planned 30 minutes, but extended the time due to engagement. Something I noticed this time was that students did not all start the same way. Some groups immediately began writing or drawing, while others sat and talked through the situation first. This was actually helpful because it showed different ways students process a problem. Some needed to verbalize first, while others needed to represent it visually. I also had to be very intentional about not stepping in too quickly. There were moments when students were stuck and it would have been easy to tell them what to do. But instead I asked questions to keep thinking with them. My role was to monitor and ask advancing and assessing questions rather than to tell students what to do. Here are some examples of the T-chart students created after reading through the scenario. I told them to write down anything and everything that came to mind. As the problem solving evolved, they realized some of the questions or need to knows were not pertinent to solving the problem. Many groups asked unnecessary questions at first. I redirected them by asking if that information was given or was needed to solve the problem. Students experienced productive struggle and were initially uncomfortable without a procedure. Some groups took several minutes before starting, which showed how uncomfortable they were without a clear procedure. Over time, confidence increased and students began using different strategies like diagrams, tables, and reasoning. One thing that stood out was how students reacted to not having a clear starting point. Some students were hesitant and unsure at first, and a few groups took several minutes before really getting started. However, once they began trying ideas, even if those ideas were not correct, they started to build confidence. This reinforced for me that struggle is not a sign that students are not learning, but actually a necessary part of the learning process. It also showed the importance of creating a classroom environment where students feel comfortable trying, failing, and revising their thinking. One group reached the correct answer of 55 minutes with about 15 minutes left. I gave a hint about thinking about a round trip, which helped other groups get there as well. Two groups found the answer online but could not explain it. I emphasized that justification matters more than the answer and had them work backwards. This moment really showed the difference between getting an answer and actually understanding the math. This moment was really important because it highlighted the difference between getting an answer and understanding the mathematics. In many traditional settings, students might be rewarded for simply having the correct answer. But in this lesson, the expectation was that they needed to be able to explain and justify their reasoning. The shift in focus changed how students approached the task and reinforced that the process was more important than the final answer. After this, I brought student thinking together by having groups share their reasoning. We compared different approaches, focusing on how they made sense of time and distance. To close the lesson, I emphasized that the goal was not just getting the answer, but being able to justify it. Students left with a stronger understanding of making sense of a situation and being able to explain their thinking. As you can see, these groups drew a diagram and added labels to their pictures and thinking. Some used the paper I provided, while others recorded their thinking on the tabletop. The tabletop image, you can see there's writing in all sorts of directions because multiple students in that group were trying to add their ideas and thinking. So in some angles, stuff looks upside down. It was great to see the groups collaborate together. Some even got aggressive with their thinking, trying to persuade other group members of their thinking. The formative assessment was based on observation and questioning during group work. Summative focused on students' written explanation of their solution and reasoning. Even students who struggled with the final answer could explain parts of their thinking, showing growth. Engagement and confidence increased throughout the lesson. One thing I found interesting was that even students who did not fully complete the task were still able to explain parts of their reasoning. This showed me that understanding can develop even if the final solution is not fully correct, which is something that I want to continue emphasizing in my teaching. It also helped me identify which students were thinking conceptually versus those who were still relying on guessing or trial and error. Students can solve complex problems without given procedures. Productive struggle led to a deeper understanding, but requires careful support. A key question I still have is how to support students who may shut down during struggle while maintaining the rigor of the task. And this final slide is referencing the two articles by O'Connor and Ortiz.